Hi everyone, so today we're going to be talking about solving quadratic equations by using the square root method. Now, up to now we've been solving quadratic equations by factoring. So here's a great example. X squared minus 25 equals 0. I know it's quadratic because the highest exponent of the equation is a 2. And so we've been setting them equal to 0 and solving by factoring. Now you might recognize that this is dots, the difference of two squares, so you'd factor it to x plus 5, x minus 5 equals 0. And then you'd set each product equal to 0 using the zero product property. So I'd subtract 5, I'd get x equals negative 5, and add 5, and x equals 5. Now we have two answers, which remember we said that the fundamental theorem of algebra tells me that that exponent tells me that I can have up to two answers to this equation. But there actually is another method when you have dots. So it's called using the square root method. Now I want you to remember that inverse operations undo the operation. So for example, addition, you can undo addition by subtraction. You can undo multiplication by division. Well, you can undo a perfect square by taking its square root. So the solving using the square root method would be a situation like this, x squared minus 25 equals 0. But instead of factoring it, you would add the 25 to the other side, isolating the square root, the perfect square, okay? So isolating the perfect square. So now we have a perfect square equaling 25. Now I can take the square root of both sides. Now remember, when we take the square root of a perfect square, we have to consider that it's an absolute value. It's a positive and a negative answer, meaning we will get both a positive or a negative 5. Why is that? Well, if we take a positive 5 and we plug it into x squared, we get 25. And if we take a negative 5 and we plug it into x squared, we'll get 25. Now, it's just two different methods, but you should get the result to be exactly the same. Well, when do we use it? Well, I use the square root method when the linear term is missing. Okay, then this is a nice option for you. The linear term, ax squared plus bx plus c. Remember, this is the quadratic term. This is the linear term because the highest exponent of this term is a 1. All right, so I look at this equation I have here. I see that there's no linear term because there's no plain old x term. So now I isolate the quadratic. I isolate the square. So first I have to divide by 3. I get x squared equals 9. And then I solve by taking the square root of both sides. So then we know that the absolute value of x has to be equal to plus or minus 3. All right, there's another time when I think it's a great time to use the square root method. That's when the equation has the square of a binomial. Then using the square root method is a nice choice as well. But you must be really careful. I want you guys to make sure that you be careful and think before you act. Think before you act. Think before you act. You first want to isolate the square, which it is here because this binomial is being squared. So I take the square root of both sides. But be careful. You must be careful. You must think before you act. When you took that square root of both sides, there is both a positive and a negative 6 because we're taking the absolute value. So we need to realize that we have both positive and negative 6 for that square root of 36. All right, so now we have to add that 5. Well, the 5 gets added. I always put it in the front. So I'm going to add 5, and it's going to go in the front over here. So I get x equals 5 plus 6, and x equals 5 minus 6. All right, guys, we're going to be practicing the square root method a good bit. We're going to be practicing the square root method quite a bit, but I wanted you to see what the overall use could be so that you have an idea of what we're going to be doing the next couple of days. All right? Great. Have a great day. Bye.